Hi everyone, thanks for joining. We are already excited here, and it's our first time speaking in the Black Hat. After we showed the BlueRepli to our boss, he said, maybe you can try the Black Hat. Now it's actually happened, and it's a big honor to be here to sharing fun things with you. For some instructions, I'm Sourcell Xu, an IoT security researcher from DB App Security Hat Lab. I really love to contribute to open source projects like PyBlueZ and PyGet. And I also own the BlueScan project, a powerful Bluetooth intelligence collector. Hope you guys will try it. And I discovered the BlueRepli. Here is my partner, Xinxin.
Hello, I'm Xinxin. This name sounds a bit mouthful in English, but it means confidence in Chinese. I work as a hardware development engineer in this project and contribute part of my work, mostly drivers, to the open source community. BlueRepli is an amazing discovery. My partner will explain the way to discover it and how it works.
So, in fact, stealthily accessing Android phones may happen to us every day, because it's difficult for us to figure out what the apps are doing behind. For example, in June this year, CCTV, which is an authoritative Chinese media, revealed some shocking privacy chaos in Android apps. Is that some well-known apps start frequently in short period, then access user files and read the Phonebook. Obviously, this is terrible. As you can see, these privacy violations, like reading the Phonebook, are all based on the installed apps. So, will it get worse? Such as, if the app is not installed in advance, and the attacker doesn't touch your phone at all, can we also steal the Phonebook, short messages, and so on? I try to start with the wireless system of the Android phone, like Wi-Fi, mobile network, and NFC. And finally, Bluetooth provides two profiles. PBAP, the Phonebook access profile, and MAP, the message access profile. As their names say, these two profiles provide services for remote Bluetooth devices to access local Phonebook and short messages. Let's see if using these two profiles can achieve our goal. Let me talk about Bluetooth profile briefly. So, what's a Bluetooth profile? There are many application scenarios of Bluetooth, and most of them are simple and small functions, such as a Phonebook synchronization, short message synchronization. There are many ways to implement these functions, but in order to allow devices from different manufacturers to work together in the same application scenario, we need a specification. And these specifications are called Bluetooth profiles. For example, PBAP for synchronizing Phonebook, MAP for manipulating short messages. And more detail, PBAP defines two roles, PSE and PCE. This device that provides the Phonebook is PSE, such as Android phones, and the device that requests the Phonebook is PCE, like Bluetooth headset, smart wearable devices, and car computers. MAP also defines two rules, MSE and MCE, which is similar to PSE and PCE, but for short messages. Besides, devices with strong functions, such as Android phones, can simultaneously play as a server or a client. Here is a previous research about the Bluetooth profile implemented by Android, the BadBluetooth. It was disclosed last year. The idea is to be a malicious Bluetooth device. First, connect the target phone with an insensitive profile. Then, when appropriate, we switch to a high authority profile to take over the target phone. For example, first, disguised as a harmless Bluetooth headset, connect to the target phone using hands-free profile. And then we convert into a Bluetooth keyboard using the HID profile. So control the target phone. But the BadBluetooth attack model requires a pre-installed malicious app. And because the collection direction of PBAP and MAP is opposite to the attack model, it can't achieve the effect I want. Thus, getting the Phonebook and short messages with no malicious app installed, and make the target phone completely insensitive. So, what can BlueRepli do? For almost all Android phones, it can steal contacts, call logs, and short messages with only one interaction with the victim. And the attacker can make this interaction very deceptive. For a well-known manufacturer, maybe more than one, it can achieve the same function but totally stealthily. It can also use the target phone to send fake messages to others. Okay, let's dive into details. For normal use, when we access the PBAP or MAP of a remote phone, it will pop up two dialog boxes. The first dialog is a pairing request. After the user agrees to pair, the Android phone will pop up a PBAP or MAP access request dialog. When both requests are approved by the user, we can access PBAP and MAP. Therefore, using PBAP and MAP to steal the Phonebook and short messages is essentially to bypass these two dialog boxes. Let's talk about the pairing request first. Why does the pairing request pop up? The first reason is that we don't have a valid link key. After we connect to the phone, since there is no valid link key, the secure simple pairing (SSP) needs to be performed according to the protocol specification. Once the SSP is complete, the link key is shared between the two devices. It will be used for subsequent reconnection authentication and traffic encryption. Another reason is that the default I/O capability of Android phones is display yes, no. Also, according to the Bluetooth specification, the devices at both ends should use numeric comparison as an authentication method. That is, both devices should display the 6-digit number for user comparison and verification. So, the pairing request with the 6-digit number has appeared. However, the Bluetooth specification also defines other authentication methods, like passkey entry or JustWorks. What if we use JustWorks? In order to use JustWorks, we need to disguise our I/O capabilities as no input, no output. This can be achieved using BT agent. On the traffic side, the transition from display yes to no input, no output can be directly using Wireshark, like this. Then you'll find the parent request dialog just disappears. Now, only the profile access request left. As you can see, we can simply pretend to be the name of a well-known application. So this dialog will become very deceptive. Like WeChat wants to access your contacts. Skype wants to access your contacts. Or Telegrams wants to access your messages. Before we talk about how to bypass the second dialog, there is a little mention. It will be important later. The no input, no output caused just works. And then just works caused AOSP to use the temporary bound. So why does the profile access request pop up? For normal use, when we request for accessing the PBAP or MAP of a remote phone, it will use our Bluetooth address in shared preference to check if we already have the permission. If no corresponding record is found, the AOSP will pop up the dialog box. If user clicks yes, our address and the permissions will be recorded in shared preference. Therefore, the next time we request permission, the dialog will no longer pop up. In simple terms, the problem with this permission verification mechanism is obvious, that we can forge Bluetooth address, just use spoof to achieve this. But there is a problem. That's a side effect mentioned earlier. We used no input, no output to bypass the first dialog. This causes just works, which in turn causes AOSP to use a temporary bound. Then the temporary bound will pass BT bound state long to the upper system Bluetooth app. After the system Bluetooth app receives this state, it clears the permission obtained by the Bluetooth address. In this case, we won't be able to inherit the permissions. To prevent the system Bluetooth app from clearing permission, we can simply fix the class of device and the HID pointing device. According to the conditional statement on the left, the BT bound state long won't be passed to system Bluetooth app. So, the permissions will not be cleaned, and we can successfully inherit the permissions. At this point, we have bypassed the second dialog. The above method does allow us to inherit permissions, but there is another problem. That AOSP will also change from the temporary bound to persistent bound, and the persistent bound will not automatically accept pairing request. So, these two bypass methods are mutually exclusive. In other words, if we bypass a pairing request, we won't be able to bypass a profile access request. Or, if we bypass a profile access request, we won't be able to bypass a pairing request. This is very frustrated me. But things turned out to be good. For well-known Android phone manufacturer, maybe more than one, they have not successfully bypassed the BT bounce along to the system Bluetooth app. So the permissions we want to inherit will not be cleared. This makes the target never feel the attack. At the same time, the media reported that the devices using the customized Android system reached 100 million in March this year. So, this is the whole picture of the BlueRepli. Since BlueRepli is suitable for near-field attacks, it is better to have a portable hardware tool than the command line tool. Next, I'll give the microphone to Xinxin. He will introduce the hardware tool.
Yes, the BlueRepli is a wonderful discovery. We believe its effect will be better on portable devices. We try to run BlueRepli on portable devices to verify the actual combat capabilities. Generally, we will use the Raspberry Pi to achieve this goal. But in this project, Raspberry Pi does have some shortcomings. Compared to designing based on Raspberry Pi, I chose a more challenging solution, designing a brand new hardware platform for it. If we do this, the device should have the following capabilities: with enough ROM and ROM to run the Linux kernel and Python interpreter, with a hackable Bluetooth radio baseband, can be output to a battery-powered operation environment, has an easy-to-use HMI. Besides, it should be small enough. Based on these needs, we need to choose a CPU, a Bluetooth baseband, and some necessary peripheral devices. By chance, I found a very amazing chip. It is called a Winner S3, which is a highly integrated SIP solution. Integrates a single-core Cortex-A7 based SoC with 108 MB DDR3 RAM in a small BGA package. This chip will simplify the carry card design, and the characteristics of integrated DDR will also make the final product much smaller. Most importantly, it has the ability to run the Linux kernel. The radio baseband uses Cypress BCM43438, which is a Wi-Fi and Bluetooth 2-in-1 chip, supported by both NextMoon and Internal Blue. These two amazing projects give the chip the ability to manipulate the physical layer data, which means it is suitable for this project. My design also equipped with a power management chip and an eMMC memory chip for Li-ion battery and data storage. But how can we combine them? Using this? No. This can't work. We need EDA tools. Hardware debugging is more complex and time-consuming. Each version of the design will take 2 weeks to obtain a sample from the PCB prototype factory. And the worst thing is, I released 6 versions of schematic and layout. But in the end, I managed to integrate them in a 2.5 by 5 cm PCB. Having a working board is just the first step. It has no soul. The soul is the software. For some reasons, Winner has not publicly released a BSP package for their chip. If we want to use it, we need to sign some NDA contracts, which is annoying for me. We are security researchers, aren't we? Thinking in this way, I download the kernel sources and some leaked binaries and open the decompiler. I wrote some necessary drivers and fixed some bugs of the existing open source drivers, including the display driver, LCD controller, Bluetooth, non-maskable interrupt controller. Finally, I ported U-boot 2020.04 and Linux long-term 5.3 to this chip. So far, we have an operation system that every security researcher is very familiar with, thanks to the open source community, and all the drivers mentioned above were published on my GitHub. The build root toolchain simplifies the task of cross-compiling necessary packages. Soon, a root file system compatible with the original POC running environment was generated. It's time to focus on the POC itself. We need a touchscreen-based UI for it. It's no way let a chip like this, S3, to run a heavy Xorg server and the traditional DE for it. Qt embedded is a commercial license, so it is not the best choice. Finally, I met LVGL. The demo of the LVGL is really cool. You are the one, I think, but I didn't expect a nightmare to be approaching me. For a GUI framework without what you see is what you get editor, the development process was full of panic. Here are some lines of code when using it. But fortunately, it became a reality. We made a turtle box for it. It is not beautiful, but it works. Our PLA printer gets this job done. Here is what it looks like, and the shell case with the screw drill. Here is the video how BlueRepli with the portable devices works. This video shows the effect of some Bluetooth profile being maliciously used. Next, Sourcell will explain some other points that may be attacked.
So, thanks to Xinxin give us a video demo. Okay, let me do some summary. In addition to PPAP and MAP, as you can see, SAP has the same problem. However, exploiting SAP usually requires the root of the Android phone. So this is more difficult. And at the same time, there are nearly 40 kinds of Bluetooth profiles. So in the future, we still have a lot of things to play. Thank you. Any questions?
Hello everyone. I'm Xinxin. I'm here. I'm very glad to join the Black Hat in here. But there is some issue in my network connection. So maybe you will see I'm lagging in front of the camera. I'm very sorry for that. In this project, I'm working for the hardware. I'm working for the hardware. Hardware works. If you have any questions, you can send it in the live discussion, and I'm trying to answer it. Thank you. Check the discussion tab. Hey, Sourcell, you seems disconnected. Hey, Rosa, can you hear me? Okay. Yes, I am seeing the question tab, but the BlueRepli itself is designed by Sourcell. I think he have some connection problem because we are in here. The network is not well for some reasons. I think I can't answer some of the question about the exploration itself. Should I phone him? He is disconnected. Okay. I will mention him in phone. I'll give him a phone call. I will give him a phone call, but he didn't answer. I give him a phone call, but he didn't answer. Okay, I think let me see. Yeah, how a sim sending attacks on iPhone might be beat volume since it wouldn't be uninteresting. Okay, let me try to answer some question. Can we just answer these questions in before we after we close the live? Yes.
Oh, okay. Can everyone hear me? Can everyone hear me? Oh, okay, okay.
Yes, we finally can hear you.
For the second question, can manufacturer do anything to protect against the deception-based attack? To fix the deception-based attack is only depend on Google. It's not it's not a responsibility for the manufacturer. It is based on Google. There is a defense for users. Is there a defense? Just turn off the Bluetooth if you just turn off the Bluetooth if you don't need to use it. And is there a patch from the AOSP project for BlueRepli? The patch. And there is no. I asked the affected manufacturer to request the CVE, but there's no more new information. Does this work if Bluetooth URL? Yes. I think this is a good question. Does this work if Bluetooth is already connected to the other device? Yes. It worked. Yeah. Yes, it worked. For the can everyone hear me? Hi, Rosa. Can everyone hear me? Oh.
I can hear you.
There, for the vulnerability-based attack, when your device pretended to be an authenticated device, does your device no need? Yes, we don't need a link key. Yes, we don't need a link key because we pretended our our capability we present our capability as a no input, no output. So we don't need a link key. We use the temporary bound. Is there a name for the hardware that you build for BlueRepli? Yes, our hardware tool is named BlueRepli Plus, and the BlueRepli Plus will be introduced in the Black Hat arsenal. There is more demo in Black Hat arsenal. Some guys says you also target on iPhone. The iPhone is only a phone that receives a short message. It is not have any BlueRepli is not affected on iPhone. The iPhone is only receive the fake message. Okay. For vulnerability, when you just here I see the chat room. For the vulnerability based attack, when your device pretend to be an authenticated device, and the attacker first wait a minute. The attacker first obtain two Bluetooth device address by scanning in the vulnerability based attack situation. The first is victim Bluetooth address, and the second is an address that has obtained the access permission of victim. Like you say, the Bluetooth headset or other device belong to the victim. Okay. Thanks. And have a poll section. Everyone can contact me via my email. I'll type my email in the chat room. Okay. Thank you, Rosa. Thank you, Rosa.
Okay. Okay, thanks everyone who joined our.
Goodbye.
join our discussion. And
I also choose the
goodbye,
channel.
goodbye, everyone.